morning to all. So today we are going to discuss about the causes of over voltages in the power system. Before entering into the types and the sources of over voltages, we need to understand why we need to study about these things. Mainly, the voltages creates stress on the insulation system. So under normal operating condition, there won't be any impact on the insulation system, but it may the continuous operation of the normal system voltage may also create the degradation of the insulation because of its thermal dissipation, the heat dissipation. If the heat dissipation is not proper, then there may be a chance to get insulation failure in normal system voltage also. But the case in over voltage is something different because the higher voltages may create a huge stress in the insulation system. So the design of insulation system is mainly depending upon the over voltages created by several sources. Now, I would like to classify the sources of the over voltages. I mean the reason why we get over voltage in the power system. Generally, we could classify into two different category. The first one is the external source and second is internal source. The external source is because of the atmospheric disturbances. We know very well that the lightning is the important factor of creating over voltages in the power system, and it is most severe also because the magnitude is unpredictable. It is purely uncertain, and the magnitude cannot be predicted. So, the impact of lightning may vary from the lower level to very high, huge amount of voltage. And then there may be one more reason for getting over voltage because of this atmospheric condition. It is called geomagnetic disturbance. We say it as geomagnetic geomagnetic disturbances. Since the occurrence of this one is not common for all the geographic condition, so we neglect this one, but we predominantly considering lightning is a reason for external over voltage. Here the lightning may be the direct lightning or indirect lightning. So we can classify lightning into two different category. One is direct. We say it as direct stroke. And second one is indirect. As of now, we want to note down only the terms. In later, when we discussing about the lightning phenomena, we will discuss about the direct and indirect stroke in detail. So right now I may classify the lightning into two subcategory. One is direct stroke and second is indirect stroke. Now I am coming into the second category of the source. It is the internal source. The internal source is nothing but the over voltage because of uh, the changes happening in the circuit condition. It means the connecting or disconnecting of the circuits or making and closing and reclosing may also create, closing and disconnecting may also create the over voltages. So because of the system nature it occurs, so the system voltage decides the magnitude of these categories, these two categories. Actually we can classify this internal source into two. One is switching over voltage and other is temporary voltage. I'll come to this topic later, but here I want to specify that the magnitude magnitude depends on the system voltage. So we need to know all these basics. Then only we could know what are the real impact of considering or going these studies in the power system. So here the magnitude is unpredictable. I told magnitude is unpredictable. But here it is predictable because it is based on the system voltage. Now I am coming to the subcategories switching over voltage and temporary over voltage. The switching over voltages are in two different nature. One, they may be unidirectional. Unidirectional. Okay. Second is oscillatory. There may be an oscillatory waveform. So the switching over voltages are usually highly damped short duration waveforms. That's why we say it as oscillatory waveform. But here temporary voltage is probably on power frequency range. So it is alternating. It is power frequency voltage, or it may be with the harmonics. It may have harmonics, that is the multiples of system frequency. So here this temporary voltage is weakly damped sustained oscillation. So from these studies, we could say that the duration of these three, lightning, switching and temporary voltage, are different. First one, lightning, very short. But the magnitude may be very high. I'm just now I am noting down for the duration. But the switching long compared to lightning. Temporary voltage simply noting down O bar F. O bar temporary voltage is very long. So we are going to discuss about the specifications of this waveform, because sometimes the switching and lighting may look like the similar kind of waveform. But here when I discussed about this unidirectional waveform, lighting is also unidirectional and switching is also unidirectional in nature. Here the switching over voltage and lightning over voltages may have either positive or negative polarity. So the direct stroke may be predominantly negative polarity. Okay? This is predominantly negative polarity. And then indirect stroke predominantly of positive polarity. We will discuss why the reason is. Okay? Now, before going to the further studies, I would like to explain uh, the specifications. What are the important specifications to be noted down about the lightning and switching? The main factor behind the over voltages is magnitude. We already said the magnitude is unpredictable in lightning, and it depends on the normal system operating voltages in switching circuits. So the first point is magnitude. Second one is wave shape. What kind of wave shape it is? And third is duration, this time. So these are the things, but technically we say it as peak value. One is peak value, or we say it as crest value, and then here the wave shape may be unidirectional positive or unidirectional negative. So wave shape may be positive or negative, or we say it as unidirectional or oscillatory. And regarding the duration, we have two different parameters. One is front time, and second is tail time. So these are the important parameters to be considered while we discuss about the lightning and switching waveforms. So these values will differentiate these two. For example, I am taking the lightning waveform. So here the magnitude, and this is the duration. And we say it as V versus T. I told already it is a unidirectional waveform, and it goes for a peak, then in shorter duration it will go for the decaying. So it will go like this. So here the time what I told is front time, tail time, and I told what is peak value. So here the peak magnitude, sometimes the peak magnitude may not be recorded inaccurate, and the beginning of the waveform cannot be recorded accurately. So the standard says 10% to 90% of the peak. Literally we can say from 0 to 90% of the peak. And here, in order to avoid the doubt in the beginning, we are taking 10 to 90%. So this is the front time, 90% of the peak. So we say it as front time, TF. And then we need to note down the 50% of the peak. It has to be noted in the tail portion. So this is the tail portion. It is a decaying portion. Decaying portion, we need to note down the 50%. So this time is noted as tail time. So this is these two are the main important parameters of deciding the nature of the waveform, whether it is lightning or switching. So for lightning, I'll note down the values for lightning. For lightning waveform, front time, is 1.2 microsecond, and tail time is 50 microsecond. So the lightning waveform is mentioned as 1.2 per 50 microsecond. Then what about the unidirectional waveform in switching surges? In switching surges, the front time is 250 microseconds. Tail time is 2500 microseconds. So the waveform is called as 250 or 2500 microseconds. So the duration, look at the duration. So the duration of the front and tail time is very important because the duration of the tail time decides the failure of the insulation, because the long duration existence of this waveform for long duration on the system insulation creates the failures. So in order to avoid these kind of insulation failures, because the insulation failure finally lead to the failure of the power system, or it may create a disastrous effect like entire shutting down of the system. So we need to take care of the proper insulation, and it has to be protected at the possible extent. So by considering all these things, we are designing the insulation of the power system. Now let me have the importance of these voltages at various voltage levels. So here I am taking uh, three different categories. One is lightning alone. Lightning over voltage. And the second category is lightning plus switching. The third category is switching over voltage alone. So the insulation design, in some systems the insulation design will be based on the first one. In some systems it has to be based on both the over voltages. In some cases insulation design should be based on the switching over voltages alone. As per the statistical information, up to 300 kV, up to 300 kV, we depends only the lightning over voltage, because the system voltage may be much lesser compared to the lightning over voltages at this level. And switching over voltages, it has to be considered when the voltage exceeds 765 kV. 765 kV and above we consider. But in between 300 kV to 765, 300 to 765 kV, we should consider both the things. So by properly designing the insulation system in a power system, we could able to give proper design of insulation and protection. So we need to consider protection also. These two, proper design of insulation and the protection, ensures, so these two ensures two things. One is reliability. The second one is quality. So ensuring these two, we could be able to avoid outages. Power cut can be minimized because of these things. So while we designing the transmission lines and power apparatus, we need to ensure these insulation levels and protection based on the over voltages occurring in the system. So this is how we could understand that the lighting over voltages and switching over voltages are predominantly studied for proper insulation of the power system, and individual theory against this individual theory and protection against these voltages will be discussed in the next classes. Thank you.